All right, so yeah, today we will just finish 2D.4. We won't move on to 2E, we'll just do 2D.4. The reason we'll do that is it gives people an opportunity to catch up on stuff they haven't done yet. We've got a couple of people away as well today. All right, so Austin Bailey, let's have a look up here. It's a very short extension on what we've been doing. We've got a very slight difference in what we understand the discriminant to mean. So I'm just going to get straight into it. Calculate the discriminant with this quadratic. It's going to be, so I've got A is 1, B is minus 2, C is 1. Here I've got the discriminant is 0. And so we've said that's one double root, okay? It's one root. So if it has one root, what does that mean for the graph of the quadratic? Well, what are roots? Roots are where it crosses the x-axis. And so crosses or touches the x-axis. Because it's equal to 0, it's going to touch the x-axis. All right, so that's what it says right at the top. We've got the 3 dot points. If the discriminant equals 0, the graph touches the x-axis. All right? Now, let's pull out our calculators and see that that's true. So we're going into graph mode. All right? I will bring it up, but it's going to take a bit too long. This is the equation we're graphing. Set your V window to standard. All right, so we've got x squared, take 2x plus 1. V window is standard, and when you graph it, okay, you can see it's just sitting on the x-axis. It's got one root. There is one value that makes the function equal to 0. All right, so that's the first one. Let's do the second one then, and we'll go ahead and calculate it. So A is 1, B is 3, C is 4. We've got 9 take 16, we've got minus 7. It's negative. Okay, it's negative, which means there's no roots. It doesn't cross the x-axis. All right? Now, when it doesn't cross the x-axis, we need to investigate, because it could be one of these two special cases, what we call positive definite or negative definite. It's going to satisfy one of these. Now remember, okay, so have a look here. Look up here, this part's important. If the discriminant is less than 0, there's no roots, which means it's not going to cross the x-axis. If A is positive, it opens upwards, which means it has to be completely above the x-axis. This is what we call positive definite, all right? If A is negative and the discriminant is negative, okay, discriminant negative, no roots, A is negative, opens downwards, that's what we call negative definite. So this is a special case. When the discriminant is less than 0, it's going to be one of these. It's going to either be completely above the x-axis or completely below. In our circumstance, we've got negative discriminant, so it's going to be one of these. We can see that A value is positive, all right? So that's going to be this circumstance. This graph is positive definite. Positive definite, there are no real roots. Okay, and if you graph this quadratic, you can go ahead and do it. It's x squared plus 3x plus 4. All right, and I'll sketch it up here for you to show you what it looks like. It's looking like this. All right, sitting completely above what we expect. Opens upwards, no roots. So that's all we're doing here. The extension is making a link between the roots, the discriminant, and the graph of the quadratic, right? So that's enough to get into 2D4. We've got a few more questions to do from that exercise.